Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the count of good integers. The problem category is of hard level, and in this problem, we are given an input which is n and k. Both are integers, for example 3 and 5. The range of n is from 1 to 10, and the range of k is from 1 to 9. The output in this scenario when the value of n is 3 and value of k is 5 is 27. And the output depends upon what is the task for this problem. In this problem, we need to count all the good integers which have the length of 3 digits, or we can say which have n digits in it. For example, if the value of n is 3, then a valid 3-digit number is 1, 2, 3, right? 1, 2, 3 is a valid number which is having n digits. So we need to count all the good integers which have n digits, okay? Now what are good integers? That's the question here, right? So any number x is considered a good number when the digits of your number x can be rearranged to form a k palindromic number, right? So it means that if you have a number, let's say 255, if this is a number, first of all, it should have n digits, right? So it is having n digits, n is 3, so it is having 3 digits. Now this number is x, for example, if this number is x, in this case, the digits of your x, that is 255, if that can be rearranged to form a k palindromic number, then this is a good integer and you are going to count it. So when we talk about this input, when the value of n is 3 and value of k is 5, the output is 27. It means that we have 27 numbers which have 3 digits, and those 27 numbers can be rearranged to form a k palindromic number. Now one of the possible number is 255, but let us see how it can be rearranged to form a k palindromic number. What is a k palindromic number? We need to know, right? A number is a k palindromic number if that number is a palindrome and is divisible by a number k, right? So what is a palindrome? Any number whose reverse is the same. For example, 121. So if we talk about 1 to 1, the reverse of 1 to 1 is 1, 2, and then 1, right? So 1 to 1 is equal to 1 to 1. It means that 121 is a palindromic number. And any number is a k palindromic number if that can be divided by k, right? What is k? K is given in the input. So 121 is not a valid k palindromic number because although 121 is a palindrome, it is not divisible by k. But 525 is a k palindromic number because this is a palindrome, right? And this can be divided by k, that is 5. So 525 can be divided by 5, and that's why this is a k palindromic number. Now let's come back to the good integer part. We were checking for a number 255. The digits in 255 are 2, 5 and 5, right? What is a good integer? Let us understand this again. That if the digits of your number x can be rearranged to form a k palindromic number. So our goal is, can we rearrange this 255 to form a k palindromic number? Yes, we can. We can take this 5, then take this 2, then take this 5, and 525 is a palindrome which is divisible by k. That is, it is a k palindromic number. So in that case, we can say that 255 is a good integer. Okay, so we are going to count it, and the output again it is 27. It means that we have 27 numbers which are of 3 digits, and that is a good integer. And I would agree with you guys that this question is complex, right? It's really complex to understand this, and you just need to break your question into few steps and try to understand it step by step. Now let me tell you how can you solve this step by step. Now one of the processes, you need to know what is your range. What I mean by range is, if the value of n is 3, what are the numbers which have 3 digits? It is going to be from 100 to 999, right? Anything less than 100, that is 99, or anything more than 999, that is 1000. It will not have 3 digits, right? And we want all those numbers which have n digits, that is 3 digits in this case. So our range is going to be from 100 to 999, right? And mathematically, you can say that 10 is to power n minus 1 to 10 is to power n minus 1. That is your range. This is going to be 10 is to power 2, that's going to be 100. And this is going to be 10 is to power 3, that is 1000 minus 1. And then you can say that your range is from 100 to 999. All the numbers which are having 3 digits, that will be within this range, 100 to 999. Now what you can do with this range? You can check for each number. For example, let's take a number out of it, 113. Then you need to check if your number is a good integer or not. Now how can you check? You need to take the digits out of it. The digits are 1, 1 and 3, right? Then you will have to rearrange these digits to form different numbers, right? And check if you can form a k palindromic number or not. So we can actually say, okay, 131 is a palindrome using these digits, but it is not divisible by k. So we are not going to count 113. Similarly, we just need to count all those numbers which are in this range, whose digits you can just rearrange and form a palindromic number divisible by k. Now this is very complex, guys. The reason is, first of all, this is brute force, and this is very complex as well. Because when you get a number like 153, which is in this range, then you will have to find all the possible permutations of your number 153. That's because you will have to rearrange your number. Rearranging means finding all the possible permutations. So what are the possible permutations for this? So first of all, how many numbers are possible with this? So we have 3 unique digits, right? So we can form around 3 into 2 into 1, 6 different permutations or 6 different arrangement for this number. It can be 153, 135, then 351, 315, then it can be 513 and 531. Like we have 6 different numbers which we can form using these digits, right? Now you will have to check for each number, is it a palindrome or not? That is going to be really complex, guys, okay? Instead of that, if we can understand what is the maths behind this, we can solve it very easily. Now let us understand the maths behind this. First of all, we are going to store a set, and this set is going to store all the palindromic numbers within your range which are divisible by k. Okay, basically all the k palindromic numbers. Now let us focus on one very important fact. We first need to find the range of our numbers, right? If the given value of n is 3, the range is 100 to 999, right? Now let us focus on the definition of palindromic number again. That is very important here, okay? If your n is odd, you have to form an odd length palindromic number, and if n is even, then in this case you will have to form a palindromic number which has even number of digits. Now when the number of digits are odd, the pattern of a palindromic number looks like ABA or ABCBA. And if n is even, then the pattern will look like ABBA, ABCCBA. For example, if you have n equal to 5, okay, you have to form a palindromic number of 5 digits. For example, 1, 2, 3, 2, 1. In this case, you will notice that the middle character is common and the first two characters are reversed, okay? So 1, 2 is changed to 2, 1. And that is the pattern, ABCBA, right? This BA is reversed here, right? In this case also, you will see the middle character is common and the other characters are just reverse of it. Then A is reversed to A. For example, if the number is 121, the middle character is common and the other characters are just the reverse of each other or the mirror image of each other. We have a common in case of odd, but if the number is even or if the number of digits are even, in this case it is 1, 2, then the reverse of all the numbers, that is 2, 1. So 1, 2, 2, 1 is a palindromic number. Of 4 length, of 6 length, you can say 1, 2, 3, then 3, 2, 1, right? So if it is starting from 1 to 3, the ending is going to be the reverse of 1 to 3, that is 3, 2, 1. Okay, and guys, this is very important to understand what is the pattern of each palindromic number. The pattern is different in case of odd number and it is different in case of even number. Okay, now why am I telling you this? That's very important. Okay, see, we are not going to check if a number 1, 2, 3 or 1, 2, 1 is palindrome or not. We are actually going to create the palindrome numbers. Okay, because we know the pattern of a palindrome number, we can create the palindrome number, right? So instead of checking a number is palindrome or not, let's create the palindromic number. For example, if you want to create a palindromic number of n equal to 3, example 5, 2, 5. So instead of checking for 525, we just need to know about 52, right? If we can create a number 52, then what we need to do is, we first need to ask one question. Do we need to create an even length palindrome or odd length palindrome? If the length is odd, in this case, you are going to ignore this last character and take the reverse of all other characters, 5 to 5, right? So if we know about 52, ignore this character, the last character, take the reverse of it, that's going to be equal to 525, right? And 525 is going to be your palindromic number when the number is starting from 52. But if the value of n is 4 or even, then you can have a number like 52 and you can just say that n is even. In this case, I don't need to ignore the last number. I can just take the reverse of all my numbers. 52, the reverse is 25. 5225 is a palindromic number. So from here we can say that instead of going from the range of 100 to 999, we can just check from the range of 10 to 99. That is, instead of going to the complete range, let's go half of the range. Okay, we can just go at the half of the range and we can form the other half of our number as a palindrome itself. Now this is going to save us from one very important thing. First of all, you don't need to loop through all the numbers, and secondly, you don't need to check if a particular number is palindrome or not. We are directly creating the palindromic numbers and then we will take all the arrangement of those palindromic numbers to find out what is the count of good integers. Okay, now to find the half range, we can just take the half of value n. Okay, the half of n is not going to be n by 2, and that's because n can be odd or n can be even, right? So it will be n plus 1 divided by 2, and that is equal to 2. For example, if the value of n is 3, then this formula will give the output as 2. And when the value of n is 4, in this case, the formula is going to give an output of 2.5. We can just take the integral part and this is going to be 2. So instead of n by 2, we need to say n plus 1 by 2. That is to handle the odd cases, okay, when the number is n is odd. So if the given n is 3, we just need to go from the range of 10 is to power half minus 1 to 10 is to power half. Earlier, we were talking about going from 10 is to power n minus 1 to 10 is to power n, right? So we need to go from 10 to 100. Actually, we are not going to take 100, okay? We are just going from 10 to 99. So 1 before 100, right? So this is going to be our range, 10 is to power half minus 1, that is 99. Now, how are we going to utilize this range? I will tell you. Now, let's say our range is 10 to 99. Now, our goal is we need to form all the palindromic numbers which are starting from this particular range. For example, starting from 10 or 11 up to 99. Okay, what are all those palindromic numbers? Okay, let's start doing it. So what we are trying to do is we are trying to form all the palindromic numbers which are starting from this range to this range, 10 to 99. For example, 23. If n is odd, you can say, okay, let me ignore this character 3 and take the reverse of other characters. So 23 and the reverse is 2. So 232 is your palindromic number. For 23 with n as odd, you can say, okay, I'm going to take the reverse of all my digits. 23 will become 32, right? So 23, 32, 2332 is our palindromic number. But the very important thing to understand is these are the numbers which you will have to ignore. And the reason is the value of k is equal to 5 in this case, right? These numbers are not divisible by 5. So if you take the arrangement of this number, let's say 232, you say, okay, I have an arrangement 223, using which I can form a palindromic number 232. But the palindromic number 232 is not valid, right? It is not a k palindromic number. So in this case, we are not going to take these numbers. Although they are palindrome, they are not divisible by k. But let us say we reached to the number 50. That's within our range, right? So with 50, you can say 50, ignore this last character because we are taking n as odd. Now the reverse is 5. So 505. This is palindrome. With 51, it is 515. And similarly, till with 59, we will have 595. So this is going to be 505, 515, 525, 535. All these numbers are palindrome and divisible by k, that is 5 as well. So in this case, these are the numbers which are significant for us. We are going to store these numbers into the set we have created, right? We have created a set where we are going to store all the palindromic numbers divisible by k, right? So we first find all the palindromic numbers, and if they are divisible by k, we are going to store it into a set, right? So now the value of n is 3, k is 5, and we have a set data because the range is 10 to 99, and this is our set which has 10 values. Now you will notice that these are not the numbers which you have got. You actually got the number as 505, 515, 595. But instead of storing it as 595, I am actually storing it as 559. The digits are same, right? 595 or 559. Okay. So these are actually the sorted data. My number was 595. If you sort it, it is going to become 559. And I will tell you the reason for this. We are having a set and we have 10 different numbers. For each of these numbers, we are going to check how many arrangement can I do for this number so that I can form different unique numbers. And that is because if I have a number 559, I can rearrange it to form 595. Or I can have some other arrangement of it that can be something like 955, and I can again rearrange it to be 595. So this is valid, this is valid, this is valid. So we have got 3 different arrangements with these digits 5, 5, 9, such that we can form a k palindromic number. Now, if I store it directly as 595, I will have a problem, and I will tell you why. Take a scenario where our numbers are 4884 and 8448. Both these numbers are palindromic numbers, right? And let us say the value of k is 4 and n is 4, right? So both are divisible by k as well, and both are having 4 digits. Now the problem is, if I take both of these digits in my set and try to find their rearrangements, they actually have common rearrangements. 4884 can be rearranged to form 4848. This can also be rearranged to form 4848. So if I store both these numbers into my set, then the problem is I'm going to count duplicate values, and I don't want to do that, right? So instead of that, what I do is I am just sorting this number and sorting this number as well. The sorting of this number is going to be same, and we are storing this number into the set so that I am storing just a unique number 4488, and using this number I can rearrange it to form 4884 or 8448. So this is the number I care about, right? So all the rearrangement of this number is going to be counted, because even if I rearrange to form 4848, this is a good integer because I can rearrange it to form 8448 or 4884. That is a k palindromic number. So what I'm going to do is I'm first going to find out all my palindromic numbers, then store it in a sorted form. Now for each of these numbers, I'm going to count how many different numbers I can form using these digits, okay? Or these digits 559 or 155 or 557. Okay, I just need to count it for each of the number and take the sum of it, and that is going to be my output. So the output in this scenario is 27, and let me show you how it can be 27. Now let us try to do it for 3 different numbers. So n is 3. Let me try for 055, 555 and 557. Now let me try with this 055 first, and let us say I take this 5 and put it in the first place. I fix this number 5 in the first place. Now in this case, I have 2 more places to fill, and I have 2 different numbers 0 and 5, right? So what are the numbers I can create? I can say 5 is fixed, so other 2 numbers can be 50 or 05. So I have 2 numbers which I can form with this 055 when the number is starting from 5, right? Now mathematically I can say that if my first number is fixed, I have 2 places to fill. So total number of rearrangement I can fill is 2 into 1. If I have 3 places to fill, it will be 3 into 2 into 1. That's basically called as the factorial. So what we are going to do is we are going to store the factorial first. We are going to create an array which has the factorial of 0, 1, 2 and 3. Up to 3 we will have the factorial of all the numbers. Then we are going to see how many spaces are left. Okay, if 2 spaces are left, the factorial of 2 is going to be 2. So we have 2 different arrangements. Now there is one more important thing which you need to understand. If you have the number as 555, okay, and if you fix the first digit as 5, let's say this one, you fix it here. Now there are 2 spaces left. Again, the factorial of 2 is 2. But in this case, you will notice that the other characters, the other digits itself are same, right? So you can form 555 or 555. That's the same number, right? You can rearrange these 2 numbers to form the same number. But how can you find it mathematically is, you will say, okay, what's the factorial of it? The factorial is 2, right? Now I have a number whose count is 2 and not 1. So I will divide this number with my count. So 2 divided by 2 is 1. So I can just form one number, okay? For example, let me explain you this. Let's say you have 4 places to fill. You have a number 4, 3, 3, 4, right? In this one, you have 4 as 2 times and 3 is 2 times. So how many combinations or arrangement can you form with this? See, you can form 4 into 3 into 2 into 1. That's the factorial, and that is going to be equal to 24. Now you can form 24 different arrangements, but since you have 4 2 times and 3 also 2 times, those are going to be repeated. So in this case, you are going to divide this 24 with this 2 first, that is 12, and this 2 first, that is 6. So instead of 24, it will be 6. 6 different arrangements are possible with these numbers of 4 length. But instead of 4, 3, 3, 4, if it would have been 4, 3, 2, 4, right? So in this case, you have 4 2 times, 3 1 times, and 2 1 time. So you will say, I will divide 24 with 2, then I will divide it with 1, and then I will divide it with 1. This is going to be 12, right? So this is how you are going to find out how many different arrangements are possible. So what you can do is, for each of the number, let's say 5, 5, 7, you are going to fix the first number to either 5 or 7, okay? What are the possible digits? And then check how many different digits I have left. I am left with 2 digits, okay? The factorial of 2 is 2, right? So I have total possibility of 2 different numbers to form, but the remaining numbers are 5 and 7. In case the first number is 5, the remaining numbers are 5 and 7, which have a count of 1 and 1. So divided by 1, that's going to be 2. So if you start with 5, you can form it like 5, 5, 7 and 5, 7, 5. But if you start it with 7, right, again you have 2 places left. You can form 2 different numbers, but the count of your number 5 is of 2 times. So you will divide this 2 by 2, and that's going to be 1. And 755 is the only digit you can form when it is starting with 7, right? So this is how we are going to find out for each of our number, each of our permutation number, that how many times we can rearrange it. And when you will count for all, you will get your answer. One very important thing is you cannot start with 0. That's invalid, okay? Starting with 0 means your other number can be 55, and 055 is actually a 2-digit number and not 3-digit number, okay? So that's the complete explanation for this problem, guys. If you want to find out the output, I will tell you. For this 055, you can form 2 combinations because you cannot start with 0. For this 555, you can form just 1 combination because all the characters are all the digits are same. For other numbers, you can form it for 3 times. So we have 8 other numbers forming 3 different arrangements. That's 24 plus 2 plus 1. That's 27. That is your output. So this is how we are going to implement it in our solution. And let me actually show you how can you code it using Python. So first of all, we need to create a data that is going to be a set to store all the unique palindromic numbers. Then what is the half of our number? N. That is going to be n plus 1 divided by 2. And then let's find the starting range and the ending range. The start is going to be equal to 10 to the power half minus 1, right? So the half minus 1 is here. And then end is going to be 10 to the power half. Now let's run a loop for h in range of start to end. So this is our range. Now let us try to form all the palindromic numbers. So convert your number to a string first so that we can reverse it easily. Then if the end is odd, in odd cases we are going to handle it different, and in even cases we are going to handle it different. So in case of odd, our number s, or we can say our palindromic number, will be equal to h plus the reverse of h, right? No. In case of odd, we need to go one character less. That is, the middle character will be fixed, right? For example, if it is 1, 2, 3, we are going to say 1, 2, and take the third character 3, and then take the reverse of 1, 2. So 2, 1. So this will be equal to 1, 2, 3, 2, 1. That is the palindromic number. So instead of taking complete reverse of it, just take the complete reverse before the last character. So we can say colon minus 1. So this is going to ignore the last character, and apart from the last character, it will take the reverse of it. So this is our palindromic number. But in case of even, the logic is going to be simple. We are just taking the reverse of our complete number. So this is how we are going to form our palindromic number. S is your palindromic number. Now we need to check if it is a k palindromic number or not. So in this case, I can say that the integer part of s, that is convert your s into integer and take a mod with k, and if it is equal to 0, that means it is divisible by our number, right? That is, it is a k palindromic number. So in this case, I can just say data.add. We actually need to sort it as well, right? So let us sort it. So sorted of s, this is going to give us an iterable. So let's join that iterable to form a string. So dot join. And what this will do is, this will sort our data or sort our palindromic number, and then again it will convert it to a string. Now after we come out of this loop, we will have all the numbers in our starting to ending range, which can form a k palindromic number. Now we just need to count how many arrangements we can create for each number, right? So let me actually create a factorial table. So let's say fact is equal to 1 multiplied by n plus 1. So if the value of n is 3, we are going from 0 to 3. Okay, 0, 1, 2, 3. And that is why this is n plus 1. Now let's run a loop for I in the range of 1 to n plus 1. And we can just say that the factorial of my current number I, that will be equal to the factorial of my previous number. So factorial of I minus 1, that will be multiplied by the current number I, right? So we have a factorial table now. We are going to use this to count all the rearrangement of a number. Now let us create a variable total that is going to be equal to 0. We are going to count all our good integers in this variable. And let's run a loop for s in data. S is our data set where we are storing all our k palindromic numbers. So this is your data set. Now let us create a counter. Okay, counter is going to be 0 for all the digits. So we have total 10 digits, right? From 0 to 9, right? So we are taking the count as 0 for now, and let's run a loop for ch in s. We are going to increase the count for all the digits we have. So it will be count of integral part of ch, that is, convert your ch to integer and just say plus equal to 1. So for example, if your s is equal to 255, in this case we are going to create a list which will initially have 10 zeros, right? And then for index number 2 and index number 5, it is going to increase the count of how many 2 we have and how many 5 we have, right? It's basically counting the occurrence of each digit in our current palindromic number. Now what we can do is we can count how many permutations we can form. Initially it is going to be 0. Now we can run a loop from d in the range of 1 to 10. It means that we are running a loop from 1 to 9, right? And we are not running it from 0. That's because the first character cannot be 0. So here we are fixing the first character from 1 to 9 only, okay? Now if the count of my current digit in my current s if that is equal to 0, then in this case we don't need to perform any operation, right? Because we do not have this digit. We can just continue from the loop. But if we have a count, then we are fixing the first character in our good integer and we are saying count of the current d minus equal to 1 because we are utilizing this digit as the first character on our number. Then how many permutations can we form? Then let's say p is equal to the factorial table for n minus 1. Why n minus 1? Because we are forming n digits and we are fixing the first digit. So we are left with n minus 1 digits. So we can just find how many factorials or how many arrangement we can form with n minus 1 digit, right? And the reason for creating this table is so that we do not need to count the factorial every time, right? So now these are the different arrangements we can form, but we also need to have one more logic for c in count. And inside this, we need to say p is equal to p divided by the factorial of your current count. Well, if the count is 0 or 1, in this case, the value of factorial is 1. There will be no effect. But if the count is more than 1, right? For example, if the count is 3, then the factorial is 6. Or if the count is 2, then the factorial is 2. So our actual permutation is going to be divided. And the reason is, if we have same number multiple times, that means the arrangements which we are creating, that will be same as well. So this is going to count only the unique arrangements. And once we are out of it, we can increase the value of this permutations, perms. And we can say perms is equal to perms plus p. And after this, we can reset the count of our current number. So it will be count of d will be plus 1 again. Okay. Then we can just come out of the loop and we can increase the value of total in case of current s. And we will do it for all the s in our data. So we can say total is equal to total plus perms. And that is going to be our output. So we can just return the value of total. When you will submit the code, you will find that this is actually a really good solution for this particular problem. And yes, all the test cases are passed, right? Memory wise and runtime wise, both, it is really good. So that's the complete solution for this particular problem. You can find the link of this solution in the description as well. And if this video helped you to understand the problem and understand the solution as well, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to my channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.